Here we have a compass. What happens when we bring the compass near an electric current flowing through a wire? The current is produced by a dry battery. Ah, the compass needle swings, doesn't it? When we bring the wire close to the needle swings. When we take the wire away, the needle moves back to where it was before. Why does this happen? Let's keep the wire fixed in one place and try it again. When we switch on, an electric current flows from the battery through the wire. And when the compass gets near the current, the needle swings, doesn't it? Let's do it once more and watch very carefully. Notice the way the needle swings. The red end of the needle points upwards, doesn't it? Let's reverse the battery. Will that make any difference, do you think? When it gets near the wire, the needle swings just as it did before. But this time, the blue end is pointing upwards. Now let's see what happens when we connect 3 dry batteries together. Here they're connected in series. When the compass gets near the wire, it swings in the same way. And the red end points upwards, doesn't it? Let's reverse the batteries. You know, of course, that an electric current flows from plus to minus, don't you? When we reverse the terminals of a battery, we change the direction in which the current flows. If we change the direction of the current and bring the magnetic needle close to the wire, the way in which the needle swings changes, doesn't it? Let's try it again with the 3 batteries connected in parallel. The needle seems to swing in just the same way as when they were connected in series, doesn't it? Let's reverse the batteries. Now what happens? The blue end of the needle points upwards. Let's experiment with some equipment that uses a much more powerful electric current. When we switch on, we produce a current of 30 amperes. Switch on. The electric current is now flowing in the direction the arrow is pointing. In this case, the compass needle points at an angle of 90 degrees to the electric wire. The blue end is upwards, the red end downwards. Let's reverse the direction of the electric current. What happens? Yes, just as we expect. The needle points at 90 degrees to the wire, but because we have reversed the direction of the electric current, the red end of the needle now points upwards and the blue end downwards. When we switch off, in other words, when the electric current stops flowing, the compass needle swings back to where it was before. This time, let's try it with the electric wire wound in a coil. The needle points at 90 degrees to the coil with the blue end upwards. If we turn the coil, and so reverse the direction of the electric current, yes, I'm sure you've already guessed what happens.